Hello. I'm sure you guys all know the game Tic-Tac-Toe. The person to get 3 in a row wins. What I've coded here is a version of Tic-Tac-Toe where it has arbitrary level recursion. What you just saw was normal Tic-Tac-Toe. Now, this is depth 2. So, I move and then basically the best way to explain it is the shaded area is the place where the next player can move. And it's the position of the small x when it's scaled up. Then the x covers the middle square, so that's where the next player can move. So if I move here, when this square here is scaled up to the big square, then the circle ends up covering this whole area, so the next player has to move here. So it just goes on like that, and then once one player gets... Actually, let me demonstrate. Yeah. Once one player wins a board, well, the board is theirs. You can't play on it anymore, and actually the move I did also sent us back to the same board. And what that means is that you can play anywhere on the whole big board, because you can't play here anymore because it's already resolved. So yeah, it just goes on until every board is either a tie or someone has won. Like this board over here is a tie. You can't play on it anymore because it's just full. So yeah, it just keeps going. I landed on a full board, so I can play anywhere. And then, let's see. Actually, I don't think this game's gonna end up with a winner, but just to demonstrate. The game doesn't have to end up with a winner, but it's still better than regular Tic-Tac-Toe because regular Tic-Tac-Toe has way too many ties. As you can see in this game, red won because they got 3 in a row. And actually, all the boards ended up getting resolved, but it doesn't have to be that way. Sometimes you can have like unresolved boards and yet still have 3 in a row. Anyway, time to demonstrate the next level my program can do. By the way, to show, here's what I'm actually doing. I'm just running it and it's asked me for the game depth. 1 is like regular Tic-Tac-Toe, 2 is ultimate Tic-Tac-Toe, and 3 I'm about to show you. So this is depth 3, so it's Tic-Tac-Toe and Tic-Tac-Toe and Tic-Tac-Toe, and it's a lot of the same concepts except for like moving. So yeah, when you win, you could win a Tic-Tac-Toe board normally, and if you win 3 in a row in one of these size Tic-Tac-Toe boards, then you win that board. And if you win 3 of those in a row, you win the big board. Except the way moving works is, say I move in the here. Say I move here. The place that the next player moves is determined by scaling up this to the size of the big rectangle. So it's like similar to depth 2, but not exactly the same. And then once again, this circle ends up covering this whole box. So that's the same concept. If the box the player should move on is like completely resolved, then the box scales up to the one bigger place, and then eventually the biggest board. And if it can't play in the biggest board, then it's just a tie. I can actually simulate some games. So let's see. Like here's an example depth 3 game for you. You could look something like this. In this example, no team wins because this board's resolved, like their ties. And then yeah, everything's done and there's nothing to be moved, so it's a tie. Sometimes someone wins actually. Try to get an example where someone wins. Oh, I'm not. Okay, yeah, see in here. Oh yeah, this is an X. It's hard to see because of the big X, but there's an X here, an X here, and an X here. So X wins the game. So yeah, it's interesting, and there's 729 squares in this. And in fact, it can even do depth 4. And I'll show you how the code works later on. The code's all by me, by the way. So yeah, 4. And so it's hard to see, obviously, but it is actually right now just generating random moves. But you could also have it on playing mode. But yeah, right in this match, no one won. This board's a tie. This is a tie, and then the big board's a tie. Yeah. So it's pretty like generalized code. It can run from anywhere from 1 to 4 depth. 5 ends up crashing usually because of performance issues. Anyway, let me show you. So there's a front end, but I'll cover the back end first. So, what I chose for representation is 0 is an empty square, -1 represents an O, and 1 represents an X. And then I'll cover this part later. Win lines, just to make it simpler to code, I just stored win lines, which are like, first of all, like a 9x9, I mean a 3x3 board is stored just as a normal list of like 9 elements. And so this refers to the possible elements that need to have the same value to be aligned, like 0, 1, 2. These are all in a horizontal line on the top row. And then it goes through all of them, like the diagonals too, just to make it easier to code. Anyway, here I define a piece. This is more for rendering and stuff and actual gameplay, so it's not really backend exactly, but I put it here anyway. I define a piece, and then I also define a string function for a piece. So like if it's like -1 is the value that represents O, so if you're printing it out, it just makes it turn to O with the string function. And then game board is the actual board. So let me explain the structure. So it's all defined using classes. So if you have like a depth 2 game, it's defined in terms of 9 depth 1 games. And each of those depth 1 games are defined in terms of 9 pieces. You can see that exact code here. It's recursion, and it works pretty well. So depth state is like the winner of the board. 0 is the board's unresolved and there's no winner yet. 1 is X is a winner. -1 is O as winner. And there's also what's the value? Actually, I forgot what the value is, but there's another value too. If I can remember, yeah. Oh yeah, -2. There's +2, yeah. That represents a board it's resolved. You can't play it anymore, but it's also a no one won. The difference between 0 and 2 is 0 means you can still play in the board. There's still spots. 2 means that it's completely done and there's no winner. It's just better. It makes it more efficient to calculate the winner and stuff. Anyways, this is the most complicated function, really. It's checking for win. So it goes through and checks the 9 boards in between, like under a board, and checks if their states are the same, basically. Like if they're all -1 or 1, and then yeah, and then there's like more complicated stuff to actually make sure that later on it's apparent. And also, when a board's condition is updated, you need to check all the higher order boards to see if their conditions haven't changed. So it's like really efficient because it doesn't check every board. It only does it based on if a sub board has been affected. String is just for printing out boards. It just converts them into a nice format for printing. And then TicTacToe. Okay, so and that's the board itself. Classic A board is for the board itself, but TicTacToe is like it actually handles the board, so it does like moving and stuff. So like modifies the board for moving. And this is actually also really complicated. This code, it's hard to get into, but it just basically makes sure that they're moving inside the move zone and nowhere else. ended. This is the winner. It prints it in the terminal. Move zone. This is more for like terminal games. Like it prints where you're allowed to move. But now it has a UI, so there's really no need for this. Oh yeah, this. Okay, so what this does is it okay, so it gets a ref like a pointer to a certain position in a certain board or like a certain board. It gets like a pointer to it by going down like the boards. Because of the way it's structured, you kind of need a function because it gets complicated to find any like random board. And then this is just for like printing out boards. Wait, this is for printing out boards. Yeah. Okay, yeah, so that's the backend. It's around 177 lines and it works for like all depths, so it's pretty actually efficient code. The front end is also around the same length. The front end does is it just like renders, so it's all also recursive, so it just generalizes to all depths. I'll explain what draw ties later. So it just draws the board and then draws all the subboards recursively until you got down to the pieces. And this is just like for moving, so when the board's clicked, yeah, it just moves. And this is just a test function I put to randomly move because I don't want to like move thousands of times. See how it like works or not. Yeah. So, let me show you some of the settings I have here. So I have window size, X color, O color. I'll explain what this is. So draw tie symbols is I actually made a symbol for ties. So if a board has a tie, I made it draw a green square on top of it just to see because it would be kind of interesting. And then draw tie shading is whether tied boards are shaded like a darker shade just to make it more obvious that they're like resolved or whether they should like stay the same. Um so yeah, let me enable this and just show you what it looks like. And that's pretty much it for this project. So let's do 3. Yes, look, this board's a tie, this is a tie, this is a tie, this, and the big board is a tie. Yeah, so it just ends up drawing a green square, just for testing, and it kind of looks interesting. So, yeah, that's pretty much it for this project, and if it gets enough interest, I guess I might post a code in the description. Total, it would get to like 370 lines, and yeah.